what happens here if you end up with a system like this and you use the addition method. Well, let's see. What's x minus x? They cancel out. What is negative 2y plus 2y? They cancel out. So what's left on the left-hand side of the equation? 0. Equals. What is 4 minus 4?
0.
What kind of a statement is this? True. This is a true statement. That means that regardless of what the variables are, right, as long as they work with, you have a solution for the first equation, it's always going to result in a true statement, meaning it's also going to work on the second equation. And what's your conclusion here? What system are we looking at? This is a dependent system, meaning that the x and the y values end up being irrelevant in the sense that once you find a solution for the first equation, it's always going to work on the second because they are really two equations of the same line. They may look a little different, but if you solve for y, both equations, they will look identical. And then you would graph them. So don't stop here with the word true. What would we write? Infinitely many solutions. You will tell me, it's not all real numbers. This is a little different than when we were doing equations with one variable. For instance, it's very obvious that if I put the number 10 and 10 here, 10 minus 20 is not 4. It's not like all numbers, all pairs of numbers are going to work. But there's infinitely many that will work. Any that work in this equation will also work in this one. So you just need to write for me infinitely many solutions.
Do we have to put many in that?
Yes.
Infinite solutions?
Infinite solutions. Yeah, I'll take that. I'll accept that. Infinitely many. Infinitely many. Infinite solutions. I don't know how I feel about using the word infinite as an adjective. You know, like 5 or. I've always. This is how I learned it. Let me think about that, but I'll accept it. To answer your question, yes. If you write infinite solutions, I'm not going to take points up for that. I'm going to keep